Healthcare systems today rely heavily on electronic healthcare records, or EHRs. These systems store highly sensitive information such as patient identities, medical histories, and billing details. While centralized databases improve efficiency and coordination of care, they also increase security risks. Healthcare data breaches are the most expensive among all industries, costing an average of 7.42 million US dollar per breach. This is because health data is very personal and difficult to replace when it is exposed. In addition, healthcare staff must frequently share data across clinical and administrative roles. This increases the number of users accessing the system and raises the risk of unauthorized access. For this reason, strong database asset control is essential to protect patient confidentiality and data integrity. In this presentation, I focus on role-based access control as a key way to secure healthcare records. Database access control defines who is allowed to read, modify, or delete sensitive data. It is one of the core components of database security. There are two main steps involved. First is authentication, which verifies the user identity. Second is authorization, which determines what that user is allowed to do once they are logged in. Several access control models exist, including directionary access control, mandatory access control, and roles-based access control. These models aim to protect confidentiality and integrity of data. Roles-based access controls is widely adopted in healthcare because it fits organization job roles and supports regulatory requirements. It also helps organizations maintain audit logs for monitoring and compliance purposes. Roles-based access control is based on three main elements: user, roles, and permissions. Users are healthcare professionals such as doctors, nurses, reception staff, and finance staff. Each user is assigned to a role based on their job function. Roles define what kind of access is required for that job. Permissions describe what actions can be performed, such as viewing patient records or updating billing information. Access follows a simple structure: user to role and role to permission. This supports the principle of least privilege, meaning users only receive the access they need to perform their work. Roles-based access control also allow role hierarchies and keep clinical and administrative access separate, which improves security and accountability. Roles-based access control is effective in healthcare for several reasons. First, it simplifies permissions management because administrators assign access by role rather than by individual user. This reduces complexity across departments. Second, it limits unnecessary access to patient information, which reduces the risk of data breaches and privacy violations. Third, roles-based access control improves accountability. Every action can be traced back to a role, which supports auditing and compliance reporting. Roles-based access control also scales well in multi-center healthcare systems where many staff members share the same database. And finally, role-based access control support healthcare privacy regulations such as HIPAA and HITECH, helping organizations meet legal and ethical obligations. Despite its benefits, roles-based access control also has important limitations. One challenge is static roles definitions. Fixed roles do not easily adapt to changing clinical workflows or evolving responsibilities. Roles-based access controls also lack context awareness. It does not consider factors such as time, locations, or emergency situations when granting access. Supporting emergency or temporary access can be difficult without creating overly broad roles. There is also administrative overhead. Large healthcare organizations may need to manage hundreds of roles, which require continuous maintenance. If roles are not carefully designed, users may receive excessive permissions, increasing security risks and potentially slow down clinical work. To address roles-based asset control limitations, other approaches can be combined with it. Attribute-based asset control introduces context-aware decisions using attributes such as time, location, and patient status. Hybrid approaches combine the simplicity of role-based asset control with the flexibility of attribute-based asset control to achieve better balance between security and usability. Layer security is also important. Asset control should work together with multi-factor authentication, encryption, and continuous monitoring. The key insight is that role-based asset control remains essential, but it is not sufficient on its own for modern healthcare complexity. Future systems must balance strong security with clinical efficiency to ensure safe and effective patient care.